Well, hopefully by now you're feeling pretty comfortable with these two-step equations, such as this. You kind of get used to seeing things in this format. Pretty soon you're doing it without really even thinking about it. You just look at it and automatically you have this habit. You add 2 to the other side. What do you do? I got 5x equals 20. Now I divide by 5, and bingo. I am at x equals 4. After a while, it becomes such a habit you don't even think about it. And then all of a sudden you run into something that doesn't look like that format, and you assume, oh, great, this must be something way different. And the trick is, it's not different at all. It's written maybe a little more user-unfriendly, but it doesn't mean that it's any tougher to solve. So what we're going to try to do, and this really is true over the next several lessons, is find things that look more complicated, but see if we can simplify them, which really means just write them a different way so that they are easier for us to use. So they kind of fit this mold right there, because that's something that we are just kind of as a habit doing without even thinking about it. So let's see if we can change things to fit that without changing what they mean. That's the key. We can't change what this variable represents in the grand scheme of things. So let's take a look at this one down here. This is a type that gives a lot of people trouble because they see, well, they see this stuff right over here and they just assume, whoa, a whole bunch of negative signs. I got these absolute value bars. That's got to be something pretty complicated. But let's jump into it and really see how complicated it actually is. Now what we're going to look at first, without even trying to solve it, we're just going to kind of take this stuff over here and just ignore it for a while. Okay? What I want to do is look at what everybody seems to focus their attention on and assume they can't figure out is that right there. Okay? What's inside here. And absolute value bars are really quite simple. Absolute value just is asking how far away from 0 is this number inside. So this thing right here, saying -2, how far away from 0 is that? And that means it is 2 units. Now all you can see from here is I took that negative sign off. And that's all you really do with absolute value. Absolute value is always a positive number. It's asking you how far away from 0 is it, not which direction. So this right here, we see in the absolute value bars, to evaluate that or to make it look better, all we do is make sure it's a positive number and get rid of the absolute value sign. So this stuff right here is now gone, including the absolute value bars. What still remains? Well, I still have this negative out here, so I got to include that. That hasn't changed. And then I got all this stuff over here. -4x equals 11. And now already this looks a lot better than it used to. I know it doesn't exactly look like this, but if you notice, we have something multiplied by the x and we have some number kind of out there by itself. Now, for some people, you will feel much more comfortable if you write it this way. So I'd encourage you to go ahead and write it that way. If you need this extra assistance, if it's something that makes it easier for you, by all means do it. So you might want to do this. It's okay to take terms, and when I say terms, I mean things separated by addition and subtraction, and write them in a different order. -2 is -2 no matter how I write it. -4x is -4x no matter where I put it. Now notice I haven't moved them across the equal sign. That's the only thing we got to watch out for. If the equal sign is right here, and these were on the left side, I can keep them on the left side. All I did was basically reverse their position. It doesn't change what they mean. And then I got 11 still over here on the right. Now I haven't solved it yet, but take a look at this. What we started with was pretty messy. That did not look very nice. But now our problem basically looks like that one up there that we just sort of solved out of habit. So I'm going to treat it like this one right here. I basically want it to look like that, so I'm just going to run with it the way it looks. I'm going to add 2. I'm left with -4x equals 13. And then I'm going to divide by -4. I'm going to divide the other side by -4. That doesn't look very good. I get this thing that says x equals 13 divided by -4. Now, if I put that into a calculator, it's not going to be a nice whole number. I could get a decimal for it, or I could just leave it alone. But there's a common misconception out there that if you get an answer that looks like this, ooh, I must have done something wrong. That doesn't look good. Well, I tell you, most numbers that are within equations aren't nice numbers. And when I say nice, I mean they don't always come out to be whole numbers. Whole numbers are no guarantee. There's lots of numbers that aren't whole numbers. Just think about money. How often you get change back at a store and it's a nice whole number? Almost never. So it's okay to get answers like this. Don't assume because you get an answer that's not a nice whole number that you did it wrong. That's simply not true. It's just a number like any other one. So I hope this gives you a little bit of insight. In future lessons, we're going to look back at equations like this that have some ugly looking stuff in them, and how can we take those and manipulate them a little bit to fit something we are used to seeing.